speaker for this breakout session on restoration solutions is Dr. Myla Aronson, she, hers. Dr. Aronson is an ecologist whose interests focus on conservation, restoration, and maintenance of biodiversity in human-dominated landscapes. Dr. Aronson received her BS in Natural Resources from Cornell University and MS and PhD degrees in Ecology and Evolution from Rutgers, the State University of New Jersey. Myla is currently an assistant professor in the Department of Ecology, Evolution, and Natural Resources at Rutgers University and the director of the Hutchinson Memorial Forest. Myla's research focuses on the patterns and ecological, environmental, and social drivers of biodiversity in urban landscapes, in particular to understand community assembly and evolutionary ecology in cities at local, regional, and global scales. She also studies best management practices and planning for biodiversity in cities. Myla has used the results from her research to direct decisions for city planning and design and restoration and management of urban green spaces. She has served on the scientific advisory committees for NYC Nature Goals 2050, Silicon Valley Urban Greening Panel, Stewardship Mapping and Assessment Project, STUMAP, in New York City and Fire Island National Seashore. Myla has taught at the undergraduate and graduate levels at Rutgers University, Luther College, and Hofstra University. Please join me in welcoming Dr. Myla Aronson.
Thank you so much. All right, I'm going to share my screen. We're all good. I assume everyone can see my screen, so.
Looks good.
Awesome, thank you. Okay, so good morning. It's so nice to talk with you today, and thank you so much for inviting me. As you can see from my title, I am going to talk a little bit about nature in cities and restoring, give you a case study of restoration in New York City. Let's see, make sure I get my slides going. Okay, so we all know that urbanization is the prevalent form of land use change and of habitat loss. Estimates of habitat loss from a recent paper, this is a recent paper came out in 2019, show that we are, of course, we're in the United States here, and estimates of over 10,000 kilometers square from habitat loss from urbanization. We're in the center of one of the most urbanized areas of the United States, as we all know, and we continue to experience rapid habitat loss. This is a picture from a figure from the same paper in which the gray are urban areas and the red are those that have recently been lost to urbanization, habitat loss. So why should we care about this, right? Why should we care? And I don't have to tell this to this group because I'm speaking to the choir here, but why should we care about nature and the concrete jungle? Cities are novel ecosystems offering unique challenges for biodiversity and restoration, but they're also where the majority of humanity lives. Over 55% of the human population now lives in cities, and so urban is actually the human experience. So the better we make our urban areas, the better for people as well as for biodiversity. Biodiversity doesn't just, I'm going to argue that biodiversity doesn't just exist in semi-pristine habitats and global biodiversity hotspots, but it's all around us. But cities are highly fragmented and disturbed. They have they're similar across the world in a high density of built structures and impervious surfaces. They experience invasions of a similar suite of non-native species due to human-mediated biotic interchange across the world, and also extinctions of indigenous species. But nature is important for us. It helps in temperature and air pollution control. It's important for recreation. By addressing biodiversity in cities, we address the global biodiversity crisis. nature allows us as both social and ecological resilience to extreme events like storms. Regulates flood. It helps us regulate flooding and water pollution. Is important for physical and mental health, and also allows for having more nature in the city allows for more experience of that nature and stewardship. So our city's really concrete jungles, so we all know they're not, right? You're here, you already care about this. We all know they're not, but the prevalent thought it has been for a long time that cities are concrete jungles, and a lot of ecologists have stayed away from studying them. Of course, in the last 20 years, that's really changed, and particularly in the last 10 years, where more and more scientists, people, but as well as scientists, are recognizing the importance of cities for nature conservation. So my group performed a study where we looked at 147 cities across the world and asked what is actually in the city? Are we seeing just a similar suite of non-native species? Are cities all just full of pigeons and phragmites, or do we see are they biodiverse? And so this was the first study of its kind, of this size, to look at cities across the world. And so we looked at floras and avifaunas. So we chose birds and plants because they're the most commonly studied in cities at that point. This was in 2014. And we found that cities, there is nature, right? So we argue there is actually nature in our cities, and it's incredibly important. Those cities that we looked at contain 20% of the world's bird species, which is a huge number, and 5% of the world's plants. But they're also, as we know, they're novel ecosystems with a mix of native and non-native species. However, if we look at just what species are in cities, over 94% of bird species are native, and 70% of plant species are native to their city. There are a few cosmopolitan species, of course. So we found pigeons to be the most common. They were found on every biogeographic realm we studied, and in over 94% of the cities. And we found a few common plant species. Poa annua, or annual meadowgrass, was found in 96% of the cities and on every continent except, of course, Antarctica, where there are no cities. But we also found that cities are unique, and they are, because of all the native species, they're actually retaining their unique biogeographic heritage, or they're retaining the flora and the avifauna of where they are in the world. So though you can, if you visit New York and visit Berlin and visit Sydney, Australia, you will see a lot of the same, you will recognize species. You'll see a lot of the same species. However, they still, those are few, there's only a few of those relative to the native species that cities can support. So where is this nature? Where can we find nature in the city? Nature in the city is everywhere, right? But in particular, they're found in urban green spaces. And we define urban green spaces as all natural, semi-natural, and artificial ecological systems within and around a city that comprise of a range of habitat types, from remnant habitats, such as all the way out over on the left, to riparian corridors, urban wastelands, managed parks, home gardens, and green roofs, but include others like brownfields, vacant lots, bioswales, and so on. And these range from across a management intensity, where some we put more management and more economic input into, but they also range in the species that they support. A green roof has the ability to support native species, but often but has less ability to support native species than a remnant habitat, for example. And so green spaces are the primary places in cities that are supporting biodiversity, and understanding how these green spaces support biodiversity and how we can restore them is incredibly important. And so why, I just talked about why a little bit, but they support the I focus on urban green spaces because they support the assemblages of plants and animals, including rare and endangered species in a lot of cities. They support the environmental functions or ecosystem services that provide, or environmental functions that provide ecosystem services like flooding retention. For example, this is a stormwater wetland in Oregon. But they also have very incredibly important social functions. They shape the character of the city and its neighborhoods. They provide a sense of place for city dwellers, and they provide a range of physical, social, and psychological health benefits that are really just starting to be studied in realizing and really the public and city planners really realizing that these green spaces are important. And the nature in those green spaces is what is providing this, the health benefits for people. So the other really important reason to focus on green spaces is because this is where people and nature interact most closely. Remember, I said earlier that the vast majority of the majority of people in the world live in suburbs and cities, right, in urban areas. And this is where humanity is interacting with nature. Yes, we go to the Grand Canyon and we go to the Smoky Mountains and the Adirondacks, the Pine Barrens. We go to all these places to interact with nature, but the daily interactions of nature are occurring in urban green spaces. And so I want to give a case study on restoring urban green spaces. It's a short study that we did in which we were interested in how do we utilize small spaces in cities, spaces that aren't used already. So margins of parks that are mowed but not used as ball fields or not used as play areas for children, roadside medians that are mowed but that's it, right? How do we restore these spaces to for biodiversity, for native biodiversity? And how do we use these to promote ecological connections among urban and natural areas of the cities, to study success of native plant species in urban areas, in particular in urban soils, and then also to promote community engagement and stewardship. And so those were the main goals of the study. And this study took place in Jamaica Bay, the Jamaica Bay area of New York. I'm here in New Brunswick. This is where Rutgers is. And we set up several parks, 10 parks across Brooklyn and Queens, in which we utilized areas of these parks, again, that weren't used, right? They weren't actively used by people, to set up a restoration experiment. And we worked with Amanda Bailey, who was a landscape architect in New York City parks, because I wanted to design these restoration experiments in a way that people could walk through them and imagine utilizing, so they were pretty, basically, right? That imagine utilizing these plants, this plant palette in their yards and gardens to promote these connections. Because yards and gardens are the most prevalent form of green space in cities, and they're all privately owned. But if we could encourage native plantings and in people's yards and gardens, we will increase biodiversity in cities and also connect. These will be these urban green spaces. I mean, these yards and gardens and native plants in yards and gardens can act as ecological connections. So, for example, pollinators, when they move as stepping stones, for example, to move to larger habitats, or for birds. And so we had four plot at each of these 10 parks. We set up 4 of these plots, and they all look like this, in which we designed them so that we had these clumpings of plant species together, and so it would look aesthetically nice. Plant species were selected by their local nativity, by their occurrence in maritime grasslands and shrublands and forests in the Jamaica Bay region, and their aesthetic qualities to encourage the use of these plant species instead of traditional garden exotics. And so they are also the last reason that, not last, but the additional reason they were chosen is that they provided food nesting sites for pollinators and birds. And so these are our plants, the mix of plant species that we chose. And we were planting these, again, I said, in these kind of interstitial areas of parks that aren't used. And so they were very different too. So this is a look at our parks. There's one here, this is a swale. This is basically kind of a swale that was mowed consistently, but never used, and people didn't walk in here, so we set up plots here. This is a side of a cricket pitch. This is a park on the side of a canal here, and this is the same site. And so what we did was we planted all of these plants, and then we measured them for growth, reproduction, and we also measured what else was coming in, so what kind of weed species. We tilled some of these to kind of turn over the soil, so that's why these two are darker and this one's lighter. And what I also want you to get from this is that the soils were very different. So we're planting all of these a little upland from where they normally grow, because we're addressing sea level rise, and when we lose natural areas due to sea level rise, where are we going to be able to restore? And that's going to be these spaces of parks and yards and gardens. And the soils are very different, right? This is a heavy organic soil. This is a sandy compacted soil, right? So urban soils are incredibly different. They're incredibly variable. They're compact. They tend to be highly compacted. They are mainly fill, right? So you might see a lot of trash in the soils, pieces of bricks, things like that. But will our native plants, how well will these communities of native plants do? And so we study the success of these. This is just an example. This is bayberry, in which we found that bayberry does much better. So this is the sites that we have, the different plots. It grows. This is how much growth and cover, its leaf area cover, and it grows much better in the very sandy soils. So it did not grow well in that or very highly organic soil. We also ran a survey. This is the last thing I want to discuss. We also ran a survey because, again, remember, I was really interested in can we utilize these restorations to encourage people to plant native plants in their yards and gardens? And so we asked, what do you think of these? We asked people walking by. We performed a survey in which we asked people what they liked, which plants they liked. And so they had to rate them on a scale of very attractive, somewhat attractive, and not attractive at all. And we added a distractor item, microstygium here, which people tended to like just as much as they liked northern bayberry, which wasn't much. So one of the species that people in general didn't like was northern bayberry, which is funny because it is actually already used as hedgerow species. But really, people loved New York aster, right? And you can see why. It's beautiful, right? It's got the beautiful purple flowers in the late summer and the fall. And so this gives an idea, though, of what types of species people are interested in. We also asked them, would you consider planting any of these plants in their yard if they're available, right? So, and vast majority of people said yes. A lot of people, about a quarter of our participants don't have a yard. live in apartment buildings. Some said no, and some said maybe. But this is important because if we sold more native plants at these big box stores like Home Depot, where majority of people are getting their plants, Home Depot, Lowe's, they would sell. People would be interested in planting these in their yards. We also asked them, what do you like about the plants shown? And they liked the plants. These are a group of plants that they liked. They liked plants that had color. So winged sumac here is beautiful in the fall, right? They like flowering plants, so that they were pretty. So flowers was a big, this is a word cloud in which words that are mentioned a lot are larger, right? The more a word is mentioned, the bigger it is in the word cloud. They like colors, flowers. There was quite a few people who talked about that their sons or daughters would like these plants. So the families would like the plants. And we also asked people what they didn't like. Oh, colors were important. So colors were important. What they didn't like. And here
we have about 3 more minutes.
Great, thank you. What they didn't like about plants, about the plants that they didn't like, so unfortunately a little wisdom here, was that color came out a large one, and that was because it didn't have enough color, right? But water and mosquitoes and bugs, this was a big one. The perception that these plants, they look messy and that they would attract water mosquitoes, which isn't the case, right? But this is what people perceive. My favorite, which is very New York, was meh. Not, just very New York, not a real reason, we don't like it. So I want to end on this. We know nature and biodiversity is important, and we can restore nature in our cities, and we can get the general public to plant native plants in their yards and gardens. But cities are built, so we can't set new, how do we encourage, so we can do those things by encouraging native plantings in our cities, but we need to do more, obviously. And so how can we build into our cities? Cities are built, we can't set up new large national parks. So what can we do? This is a report that came out of the San Francisco Estuary Institute that I advised on, called Making Nature's City. And they recommend a variety of interventions, such as increasing patch size, putting in connections, ecological connections, increasing the matrix quality, so adding habitat elements to support ecological processes and movement like native plantings in yards and gardens, increasing habitat diversity, native plant vegetation, special resources like water features or large trees, protecting those, and promoting management activities that promote biodiversity, positive biodiversity outcomes. And so, for example, in developing an urban biodiversity plan, we can start with identifying the existing resources and then expanding upon those. So this is an example of expanding patch size. Expand upon those with a combination of land acquisition, matrix improvements, and biodiversity friendly management. And so I just want to thank all of the people I've worked with in these different projects. Also, feel free to contact me. My email's here and also my website. Thank you.
Thank you, Myla. Great presentation. Our next speaker is Dr. Jessica Price, she, hers. Dr. Jessica Price works to develop and implement policies, programs, and strategies that advance climate resilience, sustainability, and environmental justice. Recently, Jessica joined the city of Madison, Wisconsin, to serve as Sustainability and Resilience Manager in the Mayor's Office. Prior to joining the city, Jessica served as Renewable Energy Strategy Lead for the Nature Conservancy in New York, where she led efforts to catalyze the transition to renewable energy and improve climate resilience, including the Long Island Solar Roadmap. Jessica has a PhD in landscape ecology and an MS in conservation biology from the University of Wisconsin-Madison, where she was a National Science Foundation Integrative Graduate Education and Research Fellow and a Doris Duke Conservation Fellow. Please welcome Dr. Price.
Good morning, everyone. I am really excited to share with you some sort of ways to marry energy and ecosystems. So I might be the only sort of energy-focused person at this morning's conference, but I hope that that by the time I'm done, the rest of you will be at least a little bit excited about the opportunities that renewable energy poses for ecosystem restoration. So I'm going to go ahead and share my screen. So I like to begin with just a little bit of acknowledgement from the folks that have made this project possible. So while I led the Long Island Solar Roadmap project, I worked with a big team of folks at the Nature Conservancy, Defenders of Wildlife, Michigan Tech University, and CBI. And so the Consensus Building Institute, sorry for the acronyms so early in the morning. And so I wanted to acknowledge them and also let you know that they are, in addition to myself, available. I'll connect you with some email addresses at the end if anybody wants to get more information and talk with them further about the project. So a little more context, this is really, it's important for us to remember New York's climate legislation, the Climate Leadership and Community Protection Act, sometimes called the CLCPA. It sets these really ambitious goals for ramping up renewable electricity generation and going to a carbon-free economy in New York with goals for 2030, 2040, and 2050. And what this really means is we're going to have to install a lot more renewable energy production. That's onshore wind, offshore wind, large-scale solar, smaller-scale solar throughout New York State. So that leads us to a little bit of math. I know it's early, but I know that you're all really smart folks and probably do math before you have your coffee in the morning. So this is the simple stuff. So the New York Independent System Operator, which runs New York's electricity grid, estimates that to reach these goals, we're going to need nearly 40,000 megawatts of additional solar. And I know megawatts is like something that's kind of hard to wrap our brains around. So that 1 megawatt of ground-mounted solar will power about 164 homes. So you can see that to really power all of New York's homes, we're going to have a lot of megawatts. And it takes about 5 acres for 1 megawatt of solar. So that's ground-mounted solar. It's a good rule of thumb. As technology advances and panels are becoming more efficient, we actually see that you can get more energy production per acre. And so that number, we're going to see that number keep going down over time. But I like to use 5 because it's a good rule of thumb. So according to this estimate, that means we'll need almost 200,000 acres to put solar panels on. If that's all ground mounted, I will say that rooftop solar takes up less space. And again, as panels become more efficient, we're getting that number down. So keep that 200,000 acres in mind. I know that sounds like a lot of space. So enter the Long Island Solar Roadmap. The question is, where are we going to put all of that solar? And that's sort of the question that was driving us. The vision for this project really was to get rapid deployment of these mid to large scale solar projects, which are quite efficient, on Long Island in ways that minimize environmental impacts, maximize benefits to the region, and expand access to solar energy. I mean, especially access to benefits of solar for underserved communities. This is really important so we can speed the renewable energy transition while protecting the environment from an ecological perspective as well as a greenhouse gas perspective. And so what we did was we mapped low impact sites for these mid to large scale solar installations. That means installations that are 250 kilowatts or larger, or about 1/4 of a megawatt. It focused on commercial and utility scale solar rather than residential ones. And so we focused on finding these low impact sites. So that means rooftops, parking lots, land areas that have been already impacted by some kind of development, such as capped landfills. And building solar on these low impact sites minimizes impacts to natural areas and habitats. It reduces the potential for land use conflicts and community opposition to solar installations, and it can decrease project cost and permitting times. in addition to avoiding the harmful release of greenhouse gas emissions when you clear land or when you convert a natural land cover over to development. And so we were really trying to be sort of solutions oriented. So instead of sort of having the conversation as conservation organizations, well, where do we not want something to be? We instead wanted to flip the script and say, where can we put this? Where can we find a solution to our renewable energy siting challenges? And so we also, at the end of the day, came up with a set of strategies to help understand what we needed to do to actually get solar on these low impact sites that we identified. So the overall approach was sort of fourfold. We did a lot of stakeholder engagement. We did public opinion research. We did economic research. And I'm not gonna get into those today because I'm gonna focus on our spatial analysis and I'm gonna connect that with ecological restoration. But I'm glad to talk with you about that. If you wanna get in touch, let me know. So a little bit of background on our spatial analysis, because this helps understand where we identified these low impact sites. So we based them on criteria that we developed with a consortium of stakeholders. We used a lot of novel land cover and land mapping techniques, a lot of GIS analysis using remotely sensed data and machine learning. And we mapped low impact sites for these 3 different kinds of solar installations. So rooftop solar, so you can see there's an example of rooftop solar here. Ground mounted solar, so you can see that over on the left of the image, and then parking lot solar, which there's an opportunity for that in the lower right of the image. Fingers crossed, they might do that too. This is actually at an SA Lauder office on Long Island. So this is this exists in the real world on Long Island. So these solutions are at play. And so you have an understanding of what it meant for us to identify those different sites. We used different land cover and land use attributes for each of the different kinds of installations. So we have rooftop, parking lot, and ground mounted. So we looked at ecological attributes. So we were making sure that we were protecting wetlands and water bodies, sensitive natural areas, and keeping out of flood zones for the most part. So we weren't putting ground mounted panels in any of those locations. We looked at contaminated areas. So it hasn't been remediated, fully remediated or not. We went with fully remediated and we could get into that conversation, but there's a lot of good reasons to only really seriously consider areas that have completed remediation if they had former contamination. And then we have our land use attributes. So we didn't put these installations in residential areas because again, we're talking about commercial and industrial solar. We said we weren't going to put any ground mounted solar in protected open space, agricultural lands that are in farmland protection programs, or areas that are designated for historical preservation. Though we did look at agricultural lands that are not included in farmland protection programs, which is a good portion. And those are areas that could be developed for anything, not just solar development. We also considered land cover. So areas with established vegetation, including grassland and forest, were not included as potential areas for solar. So I'll give you the big picture of some of our key findings. We found enough space, rooftop, ground mounted, and parking lot for almost 20,000 megawatts of low impact solar on Long Island. That's enough to power 4.8 million homes. That's more renewable energy than Long Island needs. So that's good news. We don't have to develop all of this area for solar to really start meeting the needs of Long Islanders for renewable energy. We also found that more than 80% of this potential was on private property, which means the roles of private property owners and collaborating with private property owners is very important. In our social science research, we also found that more than 90% of Long Islanders surveyed are supportive of mid to large scale solar installations. So folks understand the importance of renewable energy and they're really in support of siting renewable energy in these low impact spaces. So we also wanted to sort of quantify the benefits of what if we developed just a quarter of this? Like I said, we found way more than Long Island needs. So we found big reductions from developing just a quarter in CO2 emissions, reducing air pollution, avoiding hospitalizations and deaths over the lifetime of those solar installations, because that reduced air pollution causes real positive impacts for respiratory and cardiovascular health. It saves millions of dollars in healthcare because, again, folks are breathing cleaner air, and it creates jobs. So these are all things that are unequivocally good for our environment, our economy, and the well-being of our communities. And I'll show you a little bit of our mapping results, because what I want to focus in on is if you go to solarroadmap.org, you'll get our final report, you'll get our map. So you can actually go to an interactive map that lets you zoom in, zoom out, turn layers on and off. And so you can see where these different potential for different kinds of installations are. So the rooftops, parking lots, but I'll draw your attention to this previously developed land area. This previously developed land area is, for ground mounted solar, is the largest potential on Long Island, and I would venture to say probably in a lot of other places if we expanded this analysis. And this only includes parcels that could host, again, larger than that minimum size threshold of 250 kilowatts as a combination of these any types of installations. And so just to really quickly show you what that looks like, this is the total capacity for Nassau County. Those are the of you that are familiar for Nassau County. The darker the shade of green for a particular parcel, that's sort of an ownership of land. The darker the green, the greater the potential combined capacity that parcel could host. And so you can see that these are spread out. So most of these aren't sort of like big parcels. The development patterns on Long Island mean that our land is divided into smaller parcels than maybe out west, but that's okay because we still have a lot of potential. And this shows you in each town or city, you can see that the ground mounted is shown in these yellow bars. So for the most part, the yellow bars, the ground mounted potential is highest. You can see similar patterns for Suffolk County. Again, the darker areas can host a greater capacity of solar, and ground mounted, again, has the greatest potential. And so for most of our cities and towns in Suffolk County, you again can see that this ground mounted potential is quite high. And so I'll draw your attention to sort of back to the numbers. Okay, so again, take a sip of coffee. We're getting back into the math. So according to NYSO's estimate, we're going to need almost 200,000 acres for solar statewide. We found 36,000 acres on Long Island that you could potentially install solar installations, ground-mounted solar installations on previously developed lands. This isn't clearing forest. This isn't clearing native grasslands. These are areas that have already been developed for something. So the question that I bring to you all and thinking about habitat restoration is, what else can that land be doing? Solar energy generation is relatively passive. Once you've installed these panels, they're going to sit there humming away, creating energy all day, every day, even when it's cloudy, even when it's snowy. And so that leaves that land available to do other things. And so that land could be supporting crops and livestock. That land could be storing carbon, and that land can be hosting native habitats. So this is sort of a win-win, and we're seeing this happen more and more. People are getting more creative as landowners and communities and solar developers are really starting to take a more holistic approach and thinking about how you can get multiple uses and multiple benefits from areas that host ground-mounted solar. And so I wanted to these are things, if we sort of start thinking it through, there's a lot of benefits for native vegetation restoration at solar facilities. So we can increase habitat for plants, insects, birds, and mammals. That seems like pretty clear. If you start planting native vegetation and restoring these areas, the animals and the insects are going to be, and the birds are going to be coming in. But it also is a great way to reduce wind and water erosion. So that can be challenging in some landscapes, and planting native vegetation really starts to hold that soil in place. It improves water retention. These are really acting a little bit like prairies. Depending on what your restoration mix is, they can act a lot like prairies. And so it can improve reduce the need for fertilizers, pesticides, herbicides, so reducing those inputs, which reduces the impacts on water quality. So these can be good for water quality and retaining that water on site. And they also provide benefits. They can create this cooler microclimate beneath the panels. So solar panels actually operate best when they're not super, super hot. At the end of the day, their electronics. So you can imagine your laptop has a fan built into it, because electronics they don't operate super well when they get really hot. And so rather than putting turf grass or gravel below solar panels, if you're planting and restoring with native vegetation, it creates a cooler microclimate, which can actually make your panels operate more optimally. And I want to draw your attention that this is actually happening on Long Island. So this isn't a pie in the sky idea. There are examples of native habitat restorations at solar installations on Long Island. I'll go back one slide because this is a photo of the solar installation at Sisters of St. Joseph. I'll show you another photo in a second. They're located in Brentwood. And this is a Brookhaven National Lab. So Long Islanders are going to be familiar with the installation of Brookhaven National Labs. It's a 32 megawatt solar farm. It covers about 200 acres. The panels are spread out quite far at this installation. And it may still be, it won't be forever, but it may still be the largest solar installation in New York State. It was completed in 2011. It was by far the largest solar installation then. And it was replanted using a mix of native species, and it's still managed to retain those native species. It also has some additional features in its fencing and some of the other ways that it managed to make sure that small mammals can also use this habitat. The Sisters of St. Joseph site is in Brentwood. They actually have about a 200-acre campus there that serves a lot of functions. There's a healthcare facility, there's a school, there's residences, there's a lot going on at the Sisters of St. Joseph, and they wanted to start using renewable energy. So they built this 1 megawatt facility on about 4 acres of what was a very degraded woodland. And this was part of their restoration plan. They relocated some of the trees that were at the solar site, and they redesigned it. They worked with a landscape architect and the solar developer to design the site with ecological restoration in mind and stormwater retention. So this particular solar installation not only has native species restoration, it also has a stormwater wetland and hosts school groups, and they're really doing a lot with this site. So it's serving a lot of functions there. The Nature Conservancy actually sponsored some pollinator surveys at this site and found that compared to like other sites on campus, pollinators and birds are actually doing quite well here.
Jessica, you have 3 minutes.
Okay, great. I'm almost done. Perfect. So I do want to point out that there are some special considerations for restoring native vegetation below at solar facilities. So a lot of times this is grassland restoration. That's sort of what works best, as you can imagine, so that your plants are not shading the panels. But that means that you have to have no burn management. So oftentimes that can be a really useful tool in prairie restoration and grassland restoration, but it's not compatible for solar energy production. So that means you have to sort of develop a different management regime that doesn't use that tool is sort of taken out of your toolbox. At the same time, you have to really watch out for those binding invasives. This is one of the early lessons learned at Brookhaven, and a lesson that they've taken to heart at the Sisters of St. Joseph facility as well. So you really have to stay on top of that invasive species management more than you would at an installation where you just planted turf grass, but you're still getting those additional ecosystem benefits. It's really beneficial to include habitat restoration in the design of the array. So if you're working in a project early enough, you can make sure that the height of the array is far enough off the ground to allow for easy mowing, that the arrays are spaced far enough so that you can get your equipment that you would want in between the arrays. And then you're making sure that that's all sort of working together well. You also need to include the array in your habitat restoration design. So your seed mix is going to be different for the area below the panels versus the areas around the panels. And so you're going to want to kind of take all of that into account. And then, of course, collaboration with the solar developer and the landowner is key. We need demand for this solution. So the solar developer has to have their reasons for doing it. The landowner needs to have their reasons for doing it. And those reasons can vary, but that's sort of where the role of folks that are really interested in value habitat restoration comes in. And so I'll leave you with some resources. This is by no means an encyclopedic list of all of the resources that are out there. but I will steer you toward the Solar Roadmap report. The website, solarroadmap.org. You can access the report. You can go to solarroadmap.org/maps to get to the map. This provides a lot more detail and specifics of where these sites are on Long Island. It includes all of our 8 strategies and a bunch of actions that we need to get solar on those low impact sites. So please do go check that out. That wasn't kind of the focus of today's talk. Some states even require restoration of native prairie habitat below ground mounted solar panels. Minnesota is one example. There's actually, I think, maybe 5 to 10 states that are doing that. And the Minnesota Department of Natural Resources technical guidance covers seed mixes, planting layout specifications, as well as maintenance. It's a really, really great and adaptable resource. There's the State Pollinator Friendly Solar Initiatives resource by Clean Energy States Alliance that can steer you toward a lot more information. And then there's some like important peer-reviewed research that's going on to understand how what all of the benefits, the multiple ecosystem services that native restoration, plant restorations below at solar facilities can actually provide. And it's not lost on you all that the devil is in the details. So it's really, really important to design things well, to monitor things over time, and to make sure that you're actually getting the benefits out that you think that you should be. And so it's an ongoing process to maintain that. And so with that, I'll thank you very much. You can reach me at jprice2@cityofmadison.com. Folks that are primary contacts for this research at Defenders of Wildlife are Amy DeLaff, and Karen Liu is a primary contact at the Nature Conservancy. All right, that's it. Thank you, everyone.
Thank you, Jessica. Our next speaker is Dr. Menchyk, he, him. Dr. Menchyk graduated from Clemson University with a BS in turfgrass management and a PhD in plant and environmental science in 2007 and 2012, respectively. While a graduate student at Clemson, Nick focused on plant nutrition and physiology. Nick began teaching at Farmingdale State College in the fall of 2014. Please welcome Dr. Menchyk.
Good morning, everybody. Hopefully everybody can hear me and can see my screen. And I'm sharing the correct screen, which I think is the case here. So I'll get started. Thank you for the intro. Thank you for having me this morning. Lots of interesting things have already been said. And I think hopefully I'll add to that. I think a lot of basic things I'm going to be going over here today in a short amount of time. So just here's what I'm going to be covering. And once again, this is a rather complex topic that has a large body of research to it. And so putting together a talk for 15 or 20 minutes, trying to pick some high points or get some major ideas across is what I'm going for here. So how to map, think about soil testing. There's a lot of debate on what we should be looking at with soil tests, what those soil tests tell us, and then our control options. And I'm going to focus on the end of this talk on the effects of really glyphosate, but pesticides in general on our soil microorganisms and our soil health in general. So this is a question that I already heard this morning. Why should I care? And this is that's a valid question, but it's a question that I think maybe should be asked more often when we're looking at our soil and the ecosystem services that soil provides. I really don't think we fully appreciate it anytime we're walking across the lawn or through woods or the landscape. These soils provide a lot to us, and it's a unique resource that we have here on planet Earth. So not only does it support plant growth, certainly good and bad plants, but it will clean our water, filters water, stores carbon, provides habitat, all these things that and so we should be managing these soils in a way to protect and enhance their performance and maintain their quality and health. There are things that we can do with soils, with management choices that can improve the soil performance. There are things with the soil that we can't control. I mean, to a great degree, we can't really control slope, texture. We can't really control the climate term, but we can control other things with our management. And so we have to think about these choices and make those decisions in the most environmentally responsible way that we possibly can. So yeah, here's a little bit more about soil quality and health. These are topics or terms that have really become a lot more popular in the literature over the last 20 plus years, but they're not new terms, soil quality or health, but it's essentially how good is that soil at performing some sort of function. And this is a body of research that's ever growing, looking at water regime, the soil environment from a chemical perspective, pH, cation exchange capacity, biological perspective, everything coming together to measure how soils can perform. So there's a lot of labs out there that will perform various types of soil quality or soil health measurements and can get those data to you. So anyway, without spending too much time on that, we all know that Long Island and many of our highly developed areas in this country have disturbed environments, to say the least. Environments where the soil has been removed, where the soil probably defies classification, soils that are highly compacted, soils that have wide variety of pH values, soils that are sealed off, soils that have low biological activity, not no biological activity, but low biological activity. And then there's a lot of things that you find in there. We already heard about that, with the concrete jungle idea. In some cases, you do find chunks of concrete within that soil. And we do find a lot of other human trash and inputs and things from the activities that don't necessarily lead to a soil that has good health or good quality to support plant growth. With that said, we know the invasives can always find a way, or weedy plants always find a way, and will colonize these disturbed environments. So I think a really good idea for managers of properties, property managers, look at, well, what does my soil look like, or what should my soil look like, and what should I be finding out there? And I always like to show this. Maybe a lot of you, maybe everybody who's sitting in on this talk knows about the Web Soil Survey. Maybe some of you, this is a brand new thing. And so that's exciting for me to share because I really think this is an underutilized place to start from when we're looking at soils and when we're managing soils. This is an online database that was developed through NRCS and USDA. And instead of looking at soil survey books, old soil survey books with black and white aerial photos, you can go onto the Web Soil Survey at that URL, click on that big green button there right over here, and go and find your property, whether it's a small property or a large property. You can go on there and click that green button, find this map, put your address in over here on the left side, and what that'll do is zoom in to your area that you put. In this case, I have a picture, forgive me, it's of a golf course here, but this was from some research I did, a little project with Cornell, with some collaborators from Cornell a few summers ago, where we mapped the soils on Sunken Meadow State Park on the golf course up there. But you can define your area of interest using the tool at the top of that map, whether it's a polygon or a rectangle, and you essentially just draw out your area of interest and double click that area. And what it'll do is generate a map of that area that you just defined. And hopefully you can see on that map all the different soil types. We're going down to the soil series, so the most specific classification of soil, and you can see the names of those soils on the left side there: Carver and Plymouth Sands, Riverhead Sandy Loam. The list it continues there. You can't see all of them in that image, but you can see the areas of that area of interest that are the acres of that area of interest that those soils occupy, and the percentage and things like that. where this really shines is if you come over here and start clicking on those links, you can find a lot of information about the physical properties, about the water regime, about the soil profile itself. There's a ton of information here. When I say that, I'm not kidding you. There's a wealth of information that's up there, so you can access that data up here by clicking on those tabs up top, the Soil Data Explorer. You can download that soil data. You can find a lot of things for a relatively short amount of time in this web soil survey. Excuse me. And what I think it really helps is if you have a large property, you can kind of get an overall starting point from which you can start to make management decisions. Or it might be helpful for you to look at when you're sampling soil. Say you are sampling soil for soil testing. So you can be a little bit more targeted as to where you're sampling your soil. So what does a soil test tell us? Well, it can tell us a lot of different things, and they can be physical, they can be chemical. We can look at the nutrient concentrations. We can look at the texture, organic matter. This is a short list on the left side. We can certainly test for a lot of other things. As long as there's a methodology for it, we certainly can test for pesticide residues. We can test for really anything for the most part. Do all of these things matter? That's where you have to start making decisions. pH, texture, really important. Organic matter potentially could be very important. Nutrient concentrations, I have a hard time, confidently telling you, and I'm coming from a turf management perspective, but I have a hard time, recommending that we need phosphorus and potassium and micronutrients. But those things might be important in certain soil situations where we have maybe poor subsoil, or we just have a poor fertility in a soil, or we have situations where we have rapid drainage and leaching, and we wouldn't want to manage that soil with fertilizers or with pesticides or really anything that could get into water bodies. And certainly this is a major difference when we're looking at wetlands. So that is a whole other thing that we really don't have time to talk about today. But I do think if soil hasn't been tested, you should at very least look at pH, measure texture. Those two things can be done easily. I mean, texture can be done in the field by feel. pH can be done easily with a wide variety of really cheap solutions. These other things might be important, but they might not be in some cases. And so I like the idea of having information in which you can manage from an informed perspective. But unfortunately, a lot of times when people soil test, it relates to more fertilizer or more management that might not necessarily be needed and could ultimately be environmentally damaging. So, okay, soil test tells us a lot of things. Switching gears, I mean, there's a lot of information on that slide, but we do know that invasive plants will modify, and all plants will modify the root zone quite a bit. So there was some research from 2008 looking at garlic mustard, which is out there in full force right now, and found that garlic mustard infested areas had higher levels of nitrogen, phosphorus, calcium, some other micronutrients, and higher pH. Found that it didn't change the nitrogen availability, but it did influence the cycling of nutrients in those soils. And this was in a northern hardwood deciduous forest. So those deciduous forests are really starting to be reduced, to say the least, on Long Island, or have been reduced quite a bit, but we still have a lot of those areas in which garlic mustard is a problem. You can see at the bottom there that garlic mustard increased the rate of decomposition of the organic matter and did change the nutrient cycling phenomenon within those soils. And there are many other articles that are looking at a wide variety of other invasives and how they influence the soil chemistry. There's one from 2009 looking at Japanese stilt grass. It has very similar sort of results in terms of augmenting and changing the pH and changing the nutrients within that soil environment. And that shouldn't surprise anyone. All these plants are going to try to benefit their own life cycle and health by augmenting that environment. So that's something to think about. Look at the body of research. There's a lot of great resources out there to look at that a little bit more closely. I'm going to go quick here. I'm not going to mention too much about mechanical control options, but we have really effective mechanical control options that work well when populations of our invasives are relatively small. At least that's my personal perspective, and that's what I think makes the most sense. When we have larger populations, a multi-pronged approach, typically of mechanical and chemical, is what's needed. Big things with mechanical removal that are concerns is, if done aggressively, that mechanical control method, whether it's pulling or mowing or whatever type of equipment you're using, can cause soil disturbance. And anytime there's soil disturbance, you're opening up that soil for other invasives and other weedy plants to come in and get a foothold. So you always want to minimize that soil disturbance. You want to retain and keep as much soil and desirable vegetation as possible. So, you know, the idea of agriculture going from you till all the time to more of a conservation tillage, that kind of idea is kind of what we're talking about here in terms of not being a scorched earth policy in some cases, but being more targeted and having a lighter footprint in these areas, so you can remove the invasives and not hopefully disturb the soil enough where other invasives and other things come in there. Also, when you're disturbing soil, erosion is always going to be a problem. So try to revegetate those areas, put down silt fence or any sort of erosion control measures that are there that make sense, which are in a lot of cases required in many instances. Look and reach out to LNP. Look at what plant possibilities you have. What plants do you want to put in there? There's a lot of good research looking at what plants are desirable, what plants are native, what plants are going to provide ecosystem services in that area in replace of those invasives. And keep in mind, there's not a lot of room for those nutrients to move if you have erosion or if you have leaching on these disturbed sites. Long Island water tables are, depending on where you are, very close to the soil surface, and so those materials don't have to move very quick. So it's always important to make sure that you're doing that in the most responsible way. All right, switching gears here, chemical control options. Now, I look at chemical control options as one of many tools that you can use to control invasives. They're not the silver bullet. They are highly effective. They can be quite cost efficient, but you need to know what you're doing. And I know I'm probably preaching to the choir here in terms of the educated people in this conference, but you see a lot of really questionable management decisions all over the place. And a lot of times it's the quote unquote professional landscapers, but across the board, homeowners and everybody in between. We have to pick the best possible material for the job that gets the job done, that is safe for the environment, but has to be done by a qualified, certified applicator that has all of the equipment, has their equipment properly calibrated with all of the other information that is necessary to make a really environmentally responsible application.
Sorry,
now here's, yeah.
Sorry, about 2 minutes.
Okay, there's a lot of information here on glyphosate and soil microbes with a lot of conflicting results. And so I'll mention glyphosate here because it's by far the most widely used. And it's really effective, but it also can have non-target effects on your desirable plants. Probably the most commonly cited paper is from 2001, which was very specific in ponderosa pine in California. They found that in the lab within culture, glyphosate was highly toxic, but that was not the case in the soil itself. It actually increased microbial activity because glyphosate has a really favorable carbon to nitrogen ratio that allows it to be rapidly broken down by microbes. And that has been shown in a lot of different papers. So the long-term repeated use, at least in that paper, had minimal effect. Now, with that said, there are lots of other papers that have conflicting results. There's a large body of research out there. Here's a couple from 2013, 2014 that found that glyphosate had a negative effect on mycorrhizal fungi, which we know are ubiquitous in our landscapes and are definite benefit to our plants. And they are the rule, not the exception, to these ecosystem and these plant communities. So that's something to think about. I don't have a lot of time to. And I highly encourage you to go and look at some of these papers before you make and jump to a conclusion that glyphosate is bad, herbicides are bad, pesticides are bad. When used properly, I believe that they have a place in our management structure. So a couple of things here, basic stuff: encourage healthy plants, minimize your disruption, properly identify these plants, target juvenile weeds, at least know what those weeds look like, whether it's a woody invasive climbing vine or if it's a forb that's in the understory. Keep in mind that the herbicides are not the cure, just one of the tools to manage invasives. So a couple of take-home messages here to finish up. Know the basic properties of soil science. If you haven't tested your soil, or at the very least, if you haven't mapped your soil, take a look at the Web Soil Survey map and use that as a starting point, or at least get some information there from your soil. If you're going to use your herbicides, make sure you're reading the label. Make sure you're using the appropriate materials, the appropriate formulation for that particular landscape, whether it's a wetland or not. Make sure you're following the rules of the state that you're managing in. And here are some of those references I mentioned, the glyphosate toxicity one from 2001 up top, and some others that are there. I would be remiss if I didn't do some shameless plugging. Farmingdale State College has their annual plant sale May 3rd through May 5th, 9 to 5 on campus. Come out and join your fellow plant lovers and hopefully pick up something nice for your gardens. So with that, I guess all of us can take questions. I thank everybody for their attendance this morning, and I had a good time. So thank you.
All right, thank you, Dr. Menchyk. We'll have a few minutes for questions, but as a reminder that those seeking DEC pesticide applicator credits must also sign out with their name in the chat before they leave this session. Those seeking DEC and LACES credits must also complete the short survey available at the close of the session. All others are also invited to provide feedback through this survey. So I do have a question that I pulled from earlier in the chat. This is for Jessica, Dr. Price. Potential placement on drinking, has anyone looked at floating solar panels? Potential placement on drinking water sources such as near dams or other areas could minimize evaporation loss while also providing solar energy capture. This could also be applied in some open air agricultural water irrigation pathways.
Yeah, thank you for that question. And yes, this is a solution that's at play. There, I don't know if it's sort of happening at commercial scales yet, but I do know that there's pilot projects and testing of that very solution. It can be a little bit challenging depending on sort of, weather and your situation, especially with larger bodies of water that, can tend to get some wind and wave action. But on sort of smaller bodies of water, it's definitely something they're looking at, and potentially for reservoirs. I think some of you might be familiar with the plastic or other material floating balls that they'll put on top of reservoirs to keep evaporation from happening. And so this is an idea that folks are exploring to sort of get that dual use.
Excellent, thank you. So this is a question for Dr. Menchyk. How can legacy effects from invasive plants influence native plant restoration practices in your experience?
That's a great question. I wish I had more experience on that topic. Most of my experience is in home landscapes and lawns and things like that. I'll give an answer that probably is not sufficient here. I would be looking at, when you say, I guess, legacy, I'm assuming soil effects in that environment. There's most likely research out there that will address, or at least scratch the surface on some of those invasives. If you have a dominant invasive in that area, I would brush up on the most up-to-date research on it, and case studies. There's lots of case studies that are on it that would maybe have an effect. I mean, the allelopathic effects are significant in some cases from invasives, but I'd like to think that those things can be relatively short-lived in a lot of cases, in terms of how quickly the soil chemical environment breaks down and turns over with the activities of microbes. So, I'd be surprised if, you had, if you removed invasives, that you couldn't reestablish some other more desirable plant there with some success in a relatively short amount of time. I could be wrong, but based on my understanding of the soil chemistry, is that those things break down pretty quickly, including herbicides that break down relatively quickly. Like glyphosate, which has a half-life of days, not years or months or weeks.
Okay, thank you very much for that response. And then Dr. Aronson, how has the community or public at large involvement influenced your research on restoration in urban habitats?
As a community, so the community is incredibly important in restoration, and we all know this, right? So getting buy-in from the community is what makes or breaks the success of a restoration program, particularly in urban areas. And so, for example, in those 10 sites, we had some parks where the community was heavily involved, and some parks where they weren't. And some sites failed because we didn't have the buy-in or the involvement with the community. And so I think I think that's the big lesson. We knew that was going to happen, but also that the big lesson is that the success of urban restoration completely depends on involvement with the community.
Well, excellent. Thank you very much. So it looks like we don't have any further questions. So I want to thank our three presenters. This was a wonderful session, and I hope you have all enjoyed our sessions this morning. It is time for a break, so take the time you need to recharge, or use this chance to check out the expo, which you can find on your Zoom events lobby panel. There you can visit sponsors